Hey YouTubers, how's it going today? DIY Corner. Today what we're going to look at is the VDIAGTOOL V200 Pro. It's power probe, but it's much more than that. I've seen a lot of different videos online, reviews, instructional videos. I'm going to show you some of probably what you've already seen, but I also want to show you some things that I haven't seen in some of the other videos so far. Some of the things you can do with this tool. Really great tool for me so far. I've only had a couple weeks, but it looks like I can replace a bunch of different devices that I carry with me when I'm doing some troubleshooting. So let's get started. All right, so let's talk about the VDIAG tool, the V200 Pro. What are the components that we have with this device? So again, it's a power probe. So you've got your probe here. You've got a couple different leads here, which we're going to get to in a second, but just think of this as your ground lead. And this is a signal lead for a different tool that comes in this kit. It's an amazing kit. You've got a display on the front here, some LEDs that provide a moderately bright flashlight. It's worked so far for me. You've got a switch here that toggles between powering and ground switching, things like that. Again, stuff you've seen online. You have a toggle switch here, a selector that will toggle through different functions of this device. So the other thing is it comes with an extremely long cable. I've got this cable snaked behind my oscilloscope here in the back. And then it also comes with an extension cable. So it extends it out another 20 feet, which is insane when you're working on a vehicle or anything for that matter. If you're using the ohm meter function, if you're using the oscilloscope function of the power probe. So components I have on the bench or tools that I have on the bench are kind of what this tool does. I mean, I've got an ohm meter here or a digital voltmeter. Again, this can measure DC. This will not measure AC voltage that's higher than 12 volts, but it will measure frequency, duty cycles of fuel injectors, variable valve timing solenoids and things like that. But, I've got an ohm meter built into this, but I have an ohm meter built into this as well. I've got an oscilloscope here that, these can range anywhere from $300 and up. This actually has a built-in oscilloscope. I wouldn't say it's as accurate as this, but it's pretty darn close. And then I've got my power supply here, which is going to simulate, your car battery. But as you can see, I'm going to use it to actually function with this probe. So again, probe, cord. This is my extension cable that attaches to, my battery in my vehicle, or in this case, a power supply. So I'm just simply going to make these connections here, nice and tight. I'm going to attach it up to my positive lead, which would be my battery in my vehicle, my negative here. And then, additional accessories, if you chose, I can actually plug this into my cigarette lighter in the vehicle as well. So then I don't have the need for this connection. This simply unplugs. Plug this in here, and now this plugs right into the cigarette lighter. So pretty versatile tool. Additionally, you've got a breaker finder. So this basically sends or detects a signal that's generated by this power probe. It's an oscillating signal. We'll get to that maybe in this video or another, but basically helps you determine where there are breaks in a wire if you're working with a harness that's really difficult to navigate. And even if you're dealing with something as complex as a digital circuit like this, where you've got some wires and you're trying to trace them. But again, we'll talk about that maybe in another video. Comes with a nice carrying case. It's going to hold all of these different components. So what more can you ask for? So let's get started. We'll show you how this thing functions. All right, so let's check out the functions of the DIAG tool. So first things first, we got to power it up. So you got a power switch here. The power switch that has one slash, the indicator, powers the device up, the power probe. The second, so there's two little slashes here. If I switch it to that direction, what I'm doing is I'm providing a signal through this red conductor. Again, that I'm going to use with my breaker finder, but not today. So what we're going to be working with is the black wire here, which could be our ground or could be our power supply lead, depending on the test that we're performing. So what we're going to do is we're going to fire this device up. So once I power it up, the tool's going to power up. It's going to go into its diagnostics. So there's 4 different screens that you can see selected. So the first screen is your DC volts. So this is monitoring what you're outputting at the probe. So if I toggle the switch to the forward position, it's telling me that my battery right now is putting out 12.1 volts. That's my power supply off to the side, could be your car battery. If I switch it to the bottom side, now what I'm doing is I'm switching a ground path. Again, I'm not going to go into this as detailed as I've seen in some other videos. Maybe I can throw some links for those, but for today, I just want to show you some of the simple functions and how versatile this tool is. So again, that's my power, and I get an indicator here that tells me that I'm sending power. There's a red LED sending power through this probe. If I toggle one more time, I have an oscilloscope built into this. So this is going to measure the frequency and voltage of a signal. Super important when you're troubleshooting, like I said, fuel injectors, variable valve timing, and some other devices in your car, or other devices that are working off a 12-volt system, and this will actually give you a waveform. We'll get to that in a moment. If I toggle one more time by using this red button, now I have my resistance meter or my ohm meter. At this point, what I would do is I would use the black lead from the probe, attach it to one connection, and maybe it's a resistor, which we have here. We'll do this in a second. So the black lead would go on one connection, and on the opposite side of that resistor to measure the value, we could do it with the tip of the probe. But I'm going to show you even a better way. Instead of using this tube, this tip is removable, which is awesome. Now I can plug any kind of connections into this, not just the probe. Maybe I'm in a difficult location to access. Well, I can remove this simply by pulling it out. And what ends up happening, I'll toggle this off so I don't blind you. We actually have a banana clip lead here. So I can basically plug anything I want that has this particular connection type right into here. And now I have a flexible lead to work with off of this probe. Really, really cool idea. I'm glad they did that. That's, for me, that's worth the money right there. So we'll leave this connected for now. I'm going to power the device back up again. I already mentioned we've got LED flashlights on the front. And then the last selection, we actually have a diode tester built right in. So this is going to tell you if you have a shorted diode, what the forward bias is, what the reverse bias is. We do have a diode. We'll check that a little bit later on as well. So again, 4 different devices into this power probe. Really slick probe. Okay, so let's talk about, the voltmeter and the power enabling circuit that you have with this. So what I've done is I have a voltmeter here, a really old Fluke. So, it's not as sensitive as this. So you're going to notice a slight discrepancy in the two, but it's not because of this tool. It's because of my Fluke meter. I've already validated what I'm about to show you. So again, I've got my negative lead here from the power probe connected to my negative lead or my ground lead on the DVM, on the digital voltmeter. And then I have my positive lead here, which is going to measure my DC voltage. So again, I've removed that tip, that removable tip. I'm going to attach my banana lead here. Now at this point, I haven't enabled any power. My power is coming in through my power supply, and then eventually it's going to travel through this tool. So what I'm going to do is I'm going to enable, and now you're going to see that I'm sending 12.2, 12.1 volts out of this lead into the meter. And again, my meter is not as accurate as I'd like it to be. Perfect for this scenario though. So now I'm showing you it's actually sending 12 volts out. So really cool. This measures your source voltage, which would be the battery in your vehicle. But again, just showing you what it can do. So the other option you have now, since we have these tools connected, I'm going to disconnect my voltmeter, and I'm actually going to try and test a directional lamp that you might find in your vehicle. So I'm going to ground one of the pins here. And then what I'm going to do is I'm just going to attach it to this connection here. What I'll do is I'll enable the voltage. And now you can see I'm lighting the light just by switching. Kind of tough to do with a couple hands here, but you get the idea. Now, don't get nervous when you see the power probe reset itself. What's happening is my power supply doesn't have an adequate enough current to actually supply this. So the device keeps rebooting. So I don't want you to get nervous when you see the screen blank out. It's just because the power supply, this lamp actually requires a little bit more current to drive it. So, but you get the gist of it. I can actually test components inside a vehicle just by using this power probe. No disassembly. Walk to the back of the vehicle, front of the vehicle, because we have a long enough harness to do that, and I can do some power testing. All right, so let's check out the ohm meter function of the power probe. So again, I've got a fuel injector here. I've got some jumper leads, got a really nice kit off of Amazon. Maybe I'll put a link to that. But basically it extends the connections of my fuel injector. So what I want to do is measure the actual coil of this fuel injector. So to do that, I have my meter set on ohms. There's no polarity here. Just make my connection. Now you can see I'm measuring about 11.5 ohms of my fuel injector. Whether that's good or bad right now is a different story, but it's basically measuring resistance. So now, let's say I want to use my power probe to actually measure the resistance of this, because I don't want to carry my voltmeter with me. I can bring my power probe over. I'm going to make my connection to one of the leads, which in this case is my black lead. I'm going to take my red lead. I'm going to attach it, but I want to make sure I'm selected on resistance. And now I can make that connection. And I'm reading about 10.8 ohms. Again, these two are off just slightly. Not that important right now, but this is just showing you the functionality of this tool. Now, if I wanted to, which is crazy insane, I can switch it to my power supply source, which is my 12 volts DC. And what I'm going to do is I'm just going to fire this to see if this coil is actually going to energize my fuel injector to function. And it's tough to hear because you're hearing the beep, but I can tell you that fuel injector is actually working correctly. And it's telling me what the voltage is that I'm sending to that fuel injector at the same time. So I wouldn't have to pull out this voltmeter. It's all built right into the diag tool. All right, so let's check out the oscilloscope function of this particular device. So I'm going to change my selector button. I'm going to change it to frequency. So you're going to see some values on the screen. You're going to see max voltage, min voltage. You're actually going to see the frequency down here in the corner. So what we're going to do is we're going to use the signal generated by my oscilloscope, my test signal. And what we're going to look at, we're going to see what the max voltage is, and we're going to see what the frequency is. And how can I use this? I can use this to troubleshoot my fuel injectors, my variable valve time solenoids, and a few other devices. So just from a connection point, we've got our negative lead from the power probe going to a black lead here, which I'm going to connect to the ground on my oscilloscope. Then I have my power probe, or my red lead, or my signal that's going to attach to the test signal output of my oscilloscope. So we're going to make that connection now. So what you're going to notice right off the bat is that I've got a waveform on the screen. And that's my duty cycle. And right now it's showing a max voltage of 2.1, 2.0 with a frequency of 1 kilohertz. Now, you can obviously hear that audible tone that's letting me know that there's a duty cycle and that I have a waveform that's going from positive to negative. If I look at the screen, you're going to notice here, obviously, we have the same waveform, but now we have our 1 kilohertz signal here in frequency and about 2.2 volts, and it could be just my cursor adjustment here that we're looking at. But essentially, we're seeing the same signal on a $300 to $500 oscilloscope versus a $100 power probe that has other functions in it as well. Again, really cool functionality. Okay, so the next function I want to show you is the diode tester. So again, for connection's sake, we've got our negative lead from our power probe connected to a black lead here, which is my alligator lead that's connected here. And then the red lead going to my power probe, looking to measure, and then my diode that's actually connected right here. So what I'm going to do is, the best I can with one hand, I'm going to show you when I make the connection here onto the diode, and we'll just make that connection now. This is actually going to show you the forward bias. It's going to give you the value. Now, if I reverse these connection points, which I could do right now, we're going to measure exactly no current flow at all, which is what we want to see. Now, let's say, for argument's sake, we had a shorted diode. We could simulate that by just shorting it out, and you can actually see that we're measuring 0 ohms at this point. So that tells us that we actually have a shorted diode. Another functionality of this tool that would be built into a digital voltmeter, but it's in this particular tool. All right, so what I want to talk about next is how versatile the power probe is when we're trying to troubleshoot a fuel injector circuit. Now, you can do this while it's on the car, but for simplicity's sake, I'm trying to do it here while it's on a bench to hopefully help you understand it. So again, maybe you've narrowed a misfire in your engine down to the fuel injector. You've already ruled out, spark plug, ignition module, compression, all those things. We've narrowed it to the fuel injector. We really don't want to disassemble it because it's crazy, it takes some time to do that. But here's how we can use the power probe to actually test the fuel injector. So simple circuit here. You've got 12 volts that's supplied from the car battery. It's going to travel along this pathway through a resistive coil that's internal to the fuel injector. What happens is that signal then travels on its way to the PCM, computer controlled duty cycle, that eventually is switched to ground. Now, how can we test this with the power probe? So the first thing we can do is we can, take our power probe and imagine this is in the vehicle and our harness and our fuel injector. We've got our power lead plus coming in. Again, that red lead, which is here, is actually this feed here. So we could simply take the power probe and just measure the voltage at that point and see if we're getting 12 volts. And in this case, I can actually energize. So at this point in the video, I realized I made a mistake. Whenever you're using the power probe as an output for 12 volts, and you're connecting it to the fuel injector, you're going to want to remove the harness that's supplying power from the car battery, and then eventually the control signal that's going to your computer. Once you've disconnected that harness, then you can make up your own harness, which I've done here with these yellow connections, and then you can connect your power probe. Black lead to one side, the red lead to the other side, and then you can use the power probe to actually engage the mechanism, that coil inside of your fuel injector, and you can listen for that click. When you hear that audible click, you know that it's functioning, at least electronically. Not sure mechanically if it's strong enough. But again, this way you can test your fuel injector without removing it from the car. Once you're satisfied that it's actually working correctly, then you can reconnect your harness from the vehicle, and then you can continue on with the measurements with your oscilloscope function of your power probe. You're going to see the tests that I've done next, again, using the power probe. The fuel injector to see if it works just by making that click. And I can hear the click in this fuel injector. But let's say I had 12 volts, but it wasn't clicking. Well, my next step is the fuel injector, does it have an open circuit, this particular coil? So this coil from this point to this point can be anywhere from 10 ohms and up. But let's just say, we know what that value is per our service manual. What we want to do is we want to make that test. So the first thing I'm going to do is I'm going to switch this to resistance. And right now, it's actually telling me that it's 10.8, which tells me my coil's good on my fuel injector. So something else is causing this device to fail. Now let's just say, for instance, one of these wires had an open connection. This coil had an open connection, or the connector, the removable connector that's here, was accidentally pulled away from the actual fuel injector. This one's got a finicky tap. So at this point in the video, this is where you want to disconnect the automotive harness, and you want to make your connections with your fixture that you've created to test the fuel injector. Then you can run it through its paces, whether it clicks or not. Once you've determined that it's actually functioning correctly, then you can continue, like you'll see, with the resistance checks when you then reinstall the car harness instead of using your fixture. Hopefully this wasn't too confusing. So a couple things might happen. First thing is, I'm going to toggle to my 12 volts, and I'm going to see if I have 12 volts. I might have 12 volts because I don't have a switch path to ground right now. But if I try to energize it, I get 12 volts, but I'm not hearing the click. So something tells me either the injector has failed, or I have a bad connection between either the positive or the negative going to the PCM or the actual coil in the injector. So what's the easiest way to test that? Simply select this to resistance, and now it shows that I have an open connection, OL. So if I simply reseat this, now it's telling me that I actually have a 0 ohm connection. So now I've isolated, power's good, coil's good. Maybe it's my PCM that isn't actually switching the device to ground. Well, the next thing I can do, and we've already done this earlier, is I'm going to switch this to frequency. And what I do is I'd fire up the vehicle, and I should see some sort of duty cycle, probably with a max of 12 volts and down to 0 volts or something like that, the highs and the lows, and I might have a frequency response here. Again, that's how you can rule out if it's a failure of the PCM, or maybe you have a ground circuit here. I don't want to get too technical with this information, but it's more about the versatility of this particular tool. So I don't have to dig out my voltmeter, my oscilloscope, another power supply. I have a built-in flashlight. What more could you ask for? Okay, so let's talk about the breaker finder, that's incorporated into this particular kit. So, I haven't had a lot of use for devices like this, but this one seems to be a little bit more accurate than most of the others that I've purchased over the years. So it's a pretty simple device where it sends an audio signal or frequency through this conductive wire here, through whichever connection you apply it to. So I've got two simulated connections, one that's actually connected to the signal, and then one that is not. So again, imagine this is in your automobile, and I'm making a connection to like pin 1, and this is pin 2, but it's not connected to the signal path. So to use the breaker function, again, just to see if there's a break inside of your internal conductor, to do that, instead of switching the switch to power on the power probe, you're actually switching it to the second position, which enables that functionality. So what I'm going to do is, just by pressing this button, you'll hear a hum. So that hum indicates to me that I have no test signal right now. But if I switch on the test signal, you'll hear that oscillating tone. So from there, now what we can do, you can hear how clear it is as it travels through that conductor. But let's see the difference between a wire that's not connected to that signal path. You'll still hear the noise, but it's not as intense as what's connected to it. Even as I get closer, you can still see a significant difference. So there are some other modules or devices like this that aren't as sensitive and aren't as accurate. This one seems to be pretty accurate. While I may not use this tool as much as I would the power probe, I think this is still a great tool. So that's going to wrap up this this review for this particular tool. I think I'm really going to use it. This seems like a great tool to me. We'll see the durability of it over time. Again, it's the VDIAGTOOL V200 Pro. It seems pretty durable. The conductor seems strong. The switches seem okay. One thing I noticed online, a couple folks were saying, and it says it in the instruction manual, kind of limit the amount of times that you apply power with this switch when this probe isn't connected. Because what happens is, when you initiate that power, you're sending an arc through the conductive path of this switch. So the switch may fail intermittently and prematurely over time. So the recommendation is basically push that switch down, and then touch your connection. Then the arc is created at that particular point instead of the switch. But again, for me, this is the end. Let me know what you think. Comments, suggestions, and I'll see you next time. Have a great one.